Hello students, welcome to Turito's live classes. How have you been? I hope you all are doing great. Students, we have started with the chapter called as what is matter around us pure. Okay, so we have seen many concepts, many important concepts such as what what is a matter. Okay, then we have seen the classification of matter. Okay, matter is divided as what physically like physical classification and chemical classification. Then we started with the concept called as what solution. Are you all able to recall the concept called as solution? Is there anyone in the class who can tell me? If you know the answer, you can type that in the chat box, students, because it is very important chapter and I hope you all are revising these sessions or the concepts which we have learned so far. Have you all? Alright. So students, solution is nothing but what are the different components of solution. If I want to define a solution, I can say, or let's talk about its component. So when a solute is getting added to what? Solvent, correct? So basically these are two important components of solution, solute and solvent. Solute is lesser in quantity and solvent it is more in quantity, or it's larger in quantity, correct? We have seen one example such as what? Salt solution. So salt is getting dissolved in what? Water to give you salt solution, correct? So in this, salt is your solute, water is your solvent, correct? So that is what we have seen, the formation of solution. Then we talked about the different types of solution. Okay, it can be like category number 1 can be based on the type of solvent which we are using. Okay, so we can use water as a solvent, correct? Water as a solvent. If we are using water as a solvent to prepare a solution, that solution is known as what? Aqueous solution, correct? So aqueous is related to what? Aqua, that means water. Okay, if you are going to use water as a solvent, that type of solution is what? Aqueous solution. And opposite to that, of course, if I am not using water as a solvent, then there are some organic substances or organic chemicals. We can make use of them for making solution. So these organic chemicals are solvents. Okay, and whenever I am having a solution in which I am using organic chemical as a solvent, that solution is what? Non-aqueous solution. Alright. So that was the type of solution which we have seen, which is based on the which solvent we are using to prepare solution, correct? Let's move ahead. Then we talked about solutions like the amount of the solute is getting dissolved. Okay, that is the another category of solution. I hope I'm sure you all are able to remember those types of solutions such as what? Saturated solution. Then we have unsaturated solution and supersaturated solution. I have given you examples such as, suppose my class has the capacity of 30 students, like there are 30 benches and 30 students can sit on those benches, correct? So that time I can say the class is saturated. I cannot add any extra student. I cannot ask extra students to sit because there are no spaces in the class, right? So that time I told you that is what? A saturated class. Likewise in chemistry we have same condition. Suppose a solvent has reach up to its maximum capacity to dissolve the total amount of solute, and still if you are going to add some extra solute in the solvent will say no, there are no spaces and I am not going to dissolve, I am not going to make or create spaces to get that extra amount of solute to dissolve. Alright, that time we can say it is a saturated kind of solution. Okay. Let's move ahead and talk about unsaturated solution. Suppose today there are only 20 students who are present in my class, but I know the class has capacity to accommodate 30 students, but today only 20 students are there in the class. Students, that time I can say that that's a class is what unsaturated. That class is what unsaturated. That means more than students can come and they can sit. Okay, so that is what unsaturated class. Likewise, in chemistry we have unsaturated solution. I have given you examples such as what 36 gram of sodium chloride can get dissolved in 100 gram of water. Okay, that means 36 gram is the maximum capacity of a salt to get dissolved in what? Water. Or water can dissolve 100 gram of water. Okay, so emphasize on the word 100 gram of water can dissolve 36 gram of NaCl. Correct? So that is its maximum capacity. Suppose I have added only 30 grams of NaCl in 100 gram of water. So students, actually I can like this type of solution is what? Unsaturated. It's not saturated. We haven't reached up to its maximum capacity. So what it what is its maximum capacity is what? 36 gram of sodium chloride. That means there is a scope, or we can add extra 6 gram of NaCl in what? 100 gram of water. Correct? So that is why we say the solution which we obtain here is what? Unsaturated solution. It is what? Unsaturated solution. I hope it's clear. Are you able to revise it? Okay, so let's move ahead. And we have supersaturated solution. What do we have? Supersaturated solution. Suppose this is the solution which I have taken, and let's stick to the same example. We are having 100 gram of water. Okay, this is what is 100 gram of water. To this you have added 36 gram of NaCl. Okay, and the solution is what? Homogeneous. Solution is what? Homogeneous. Correct? And now I can say it is what? Saturated. Okay, so it is saturated solution, and to this if you are going to add extra 5 gram of NaCl, if you are going to add 5 gram of NaCl, okay, so you are adding extra solute in the saturated solution. Definitely it is not going to get added, it is not going to get dissolved completely to give you a homogeneous solution, because it is already saturated. But what if I am going to provide the heat to the system? What will happen? Students, the molecules are going to get extra charged. Okay, they are going to get extra activated, because we are supplying heat to the molecules of the solution which is saturated. Now what will happen? Their kinetic energy is going to get increased, and that's how they are going to move here and there. Now while doing it, actually they are creating some spaces, and these spaces can get filled by the extra 5 gram of NaCl which we have added. Okay, so now this time when we supply heat to the solution, actually what happens? 5 gram of NaCl gets added completely, or I mean it gets dissolved completely, and now I can achieve the next level solution. The state of that solution will be what? Supersaturated. Okay, so you have taken saturated solution, and into that you have added extra salt, but how? By heating it, right? So that is what saturated solution, but definitely it is a temporary kind of solution. When you are going to cut off the heat supply, or you are going to cool down the solution, the extra solute which we added in a way forcefully, okay, is going to get reappear. Okay, after cooling or after some time, it is going to we are able to see the crystals are getting what the reformation of crystal will be there. Correct? So that's how we have covered the type of solution based on the amount of solute which we have added in the solvent. Correct? So after that we have talked about very important concept, that is what? Solubility. Then we covered about factors affecting solubility such as what? Temperature and pressure. So what do you mean by solubility? It is nothing but the maximum amount of solute in grams which can be dissolved in 100 grams of the solvent. Just now I have given, we just have seen one example, 36 gram of NaCl. Okay, 36 gram of salt can get dissolved in what? 100 grams of water. I am just going to write it here. 36 gram of NaCl can get dissolved in what? 100 gram of H2O, that is water. So this is the solubility, okay, which we are talking about here. I am giving you one example. So this becomes its maximum amount of solute, that is salt, which can dissolve in 100 gram of water at a given temperature. To form a saturated solution is called the solubility of the solute in that solvent. Okay, so that is the concept called known as what? Solubility. And here I have given like solute is getting dissolved in solvent to give you solution. All right. So then we talked about the like concentration of solute in a saturated solution is the same as the solubility of the solute at that temperature. Yes. So that is what we have discussed. Like then we talked about, if I am not wrong, yeah, like we saw the combination of the solutions such as solid and liquids, and we studied about their solubility. Okay. So what happens when we add solids in liquids, how temperature is going to affect the solubility. I think you are able to recall each and every concept. As we are going to increase the temperature, solubility is going to increase, correct? And here we talked about like pressure. So like pressure decreases, temperature increases, and can solubility decreases. So I explained about this term, if you all are able to recall it. Okay, so we have taken the system here. Okay, so now here initially we are going to like it is the state where we haven't applied the pressure, but as soon as you are going to apply the pressure, definitely intermolecular spaces is going to get reduced. Okay, so there are no extra spaces, so that we can add the solute in the solution, so that it will get soluble. Okay, so that's why we can say like when a pressure decreases, temperature if we are, yeah, again we are going to talk it in with respect to temperature. If you are going to decrease the pressure and you are going to supply the heat, that means what you are doing, or you are adding the heat to the system, or you are increasing the temperature. That time here we are talking about the gaseous substance or gas like a solubility of a gaseous substance, that is going to get what? Decrease. In the case here, if we are going to increase the pressure, temperature is going to get decrease. If this is the chemical condition which we are maintaining, here cooling is happening, here heating is happening, that time we say gases are going to get soluble. And we have covered like how it happens, the proper mechanism I have explained in the last class, right? Based on that, I am sure we have solved some examples, correct? So what we are going to do in today's session, okay? So after like revising the last concept, it's time to understand like what we are going to understand, like what we are going to learn in today's session. We are going to understand what true solution is, okay? So students, try to understand, we are moving ahead in the chapter, okay? It's a brand new session where we are going to understand what true solutions are, what are the different properties of solution. There is the term called as concentration of solution, which we are going to learn soon, okay? And I have planned some numericals, I have kept some numericals so that we can practice the term concentration of solution. Okay, so that is all for the day, students. This time, like as always, I am just asking you all to grab your notebook and pen so that you can note down each and every point. Okay, and of course, we are dealing with some numericals this time. So we are having the next category, students. So we have completed two categories like to understand what are the solution or what are the different types of solution, correct? So here we are having like the classification of solution, which is based on the solute particles, or more specifically the size of the solute particles which we are adding in the solvent. Okay, firstly we have studied the classification or types of solution, which was based on the what kind of solvent are you using, whether it's water or it's not, it's any other organic solvent, aqueous and non-aqueous. Then we talked about the how much solute are you dissolving in the solvent. Based on that, we have seen saturated, unsaturated and supersaturated solution. Now we are going to understand the next category, which is based on the size of the solute particles. Okay, Based on this, we have true solution, then we have suspension and colloids. Okay, so students, pay attention. This is something very new which we are going to learn. Okay, so here we are going to talk about the solute particles. Okay, the particles of solute, like size of the particle of solute is like differing in true solution. It differs in suspension. It is differs in colloids. And based on this, we have given name to that type of solution. First is true solution, second is suspension, and next is colloids. Okay, so we are going to understand their properties one by one. In today's session, we are going to talk about true solution. All right. So, what do you mean by a true solution is? Suppose students, I have taken, it is very simple to, it's very easy to understand. So, just pay attention. I have taken some water, okay, and to this, if I am adding certain amount of salt, it is going to get what? Dissolved after some time. Okay, tell me the appearance of the solution. It is homogeneous or heterogeneous? Which one? Yes, it is going to give you homogeneous type of mixture, correct? Homogeneous type of mixture, can anyone please tell me what do you mean by homogeneous type of mixture? Students, these are some fundamental concepts, and again the repetition should be there, revision should be there, so that it will retain in your head, in your brain. Okay, so that's why I am asking you all whatever the concepts which we have already covered, and whenever they are reappearing in the next session or concepts, I just want answers from you all, because we have already covered it. Homogeneous mixture. So homogeneous mixture are those type of mixtures basically where solute and solvent are getting dissolved uniformly. Okay, so suppose I am taking water, like solution from here and solution from the bottom, okay, and it's a salt solution. So what will be the taste of the solution? Suppose this is A, this is B. If we have taken two samples from the same solution, so what do we think? The salt is going to remain, it's going to spread uniformly. That's why the taste is what? Salty, no matter from where you are going to take that solution out from the solution out from the container, correct? So that means the salt particles and water molecules are what? They are uniformly spreaded, all right? They are uniformly spreaded. That's why I can say it's a homogeneous mixture. Also, we are not able to differentiate between the phases or the boundaries or the layers. Okay, what we observe, what we see, let me share the screen. Let me share the picture. So, after the dissolution, we are going to see one single phase. Phase as in, I am not able to see, I won't be able to see that there are some solid particles, there are some liquid particles. No, it will be a liquid, a solution which is homogeneous. Okay, one single phase will be there, correct? There won't be any separation between the solvent and solute which we have added, correct? So, it's a homogeneous mixture. So, true solutions are of like what kind of what is their type? They are of homogeneous types, okay, homogeneous type of mixtures. The components of solution do not chemically react with one another. So, here we have added salt or we have added sugar to water, right, and after some time we have observed that it is a true solution or it is a homogeneous kind of mixture. Students, we know that it is a mixture. First of all, it's a mixture, and we have studied the properties where we talk about like the components of mixtures are not going to get bonded with each other chemically. Okay, so there is no new substance with all new properties. Okay, there is no such formation of new substance happens. That's why we say the components of solution do not chemically react with one another. They are not going to get bonded. They are not going to get gelled up in a way that they are going to producing a new substance altogether. Okay, that's why we say they are not chemically bonded. Is that followed? All right. Now, here is the important part. Okay, the size of the particles are smaller than 1 nanometer. Okay, the particles which we have in the solution, the size of this particle is what? It's less than 1 nanometer, okay, which is like 1 nanometer is equal to 10 raised to minus 9 meters. 10 raised to minus 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's that small. We can't even imagine, right? So, it's a 1 nanometer, which is 10 raised to minus 9 meter in size. So, they cannot be seen through naked eyes. Just imagine you are holding salt solution. Can we all see each and every particle there? No. That's why we say that particle size is very small, or it is such a small that we cannot see them through our naked eyes. Okay, so what is the next solution? Can we use microscope and see them? No, they are very small that we cannot see these particles under a microscope. Okay, and that is what its special properties. Okay, I told you that this solution, like we have the next category of the solution, which is based on the size of the particles. So, here size of the particles of true solution is what? 10 raised to minus 9 or meter, or 1 nanometer, even less than 1 nanometer, alright. So, the size of the particles is what? Smaller than 1 nanometer. Okay. So, quickly make a note of this thing, students. Give heading as what? True solution. Properties of true solution, it's a homogeneous one. Okay, and definitely they are not solute or solvent, or the particles are not going to get bonded chemically with each other. Second, third, which is the most important, the size of the particles is less than 1 nanometer. Okay, quickly. So, there will be so many questions, students, which is based on this topic, okay, for your Olympiads or any competitive exam. It is their favorite area. From this they are going to ask some questions, alright. Let's move ahead. So, here, because of small size, particles do not scatter beam of light passing through the solution. Suppose we have taken the solution in a beaker, and now with the help of torch you are going to pass some light on that solution. What happens? What do we observe, students? That here is the image. Let me share it. Okay, I hope it's clear to you all. Focus on this is the diagram A, this is B. As of now, just focus on diagram A. So, this is what is the torch, and we have focused light on the solution. This is the true kind of solution. Okay. So, particles are having a size like less than what? 1 nanometer. Alright. When we are going to pass a beam of light through this solution, okay, these are the particles. So, what do we see? That beam of light not visible inside true solution. We don't see that the scattering of light is happening inside this solution, right? So, this is a true solution. They have taken the sugar solution. So, we are not able to see that particular beam which we have passed through this torch. Okay, that means the light is not getting scattered, it is not getting spread through these molecules. If it would have done, we would have seen the path of that light, path of that beam. Here in case of example B, we have taken colloidal solution, okay, which is not a true solution. Now, what is colloidal solution? What are its properties? We are going to cover it ahead. But here, try to understand. I just want you all to compare it with the colloidal solution. So, colloidal solution has this property that when we are going to pass a beam of light over the solution, here this shows that okay, this area is covered by this beam of light. Scattering of light is happening. Okay, so beam of light is visible inside a colloidal solution, and that is what is the difference between true solution and colloidal solution. Ahead we are going to cover the same property, but here try to understand true solution do not scatter the light, okay, or the beam of light which we are passing in it, it is not going to show, or it is not visible inside true solution. No scattering of light will be happening here. Okay. whereas it is being shown or it is being seen in the case of what? Colloidal solution. Okay. So, why it is happening? Because of small size, particles do not scatter beam of light passing through the solution. Okay, they are very small, we are not even able to see the beam of light which we have supplied. Okay, therefore, the path of the light is not visible. The path of the light is not visible, and it is very important property of true solution. So, quickly make a note of this point too. Okay. The particles of the solute in solution pass through the filter. Okay, this is the next property. I will just discuss this afterwards. Have we all finished with this property? No scattering of light happens in true solution. That's it. Okay, moving ahead. The particles of the solute in solution pass through the filter paper. Therefore, that solute particles are smaller than pores of that filtered paper. So, solute cannot be separated by filtration. So, what happens if we want to filter the solution, if we want to separate the components of the solution, when we talk about true solution, what happens? The particles of the solute in solution pass through the filter paper. Okay, suppose this is what is a just a minute. Okay. This is what is the funnel, and to that if you have poured some true solution and we are having a filter paper here. Okay, this is the solution which you are going to pour. This is true kind of solution. Okay, try to understand, this is a beaker and through which you have poured some solution on the paper, and definitely we are going to collect it. Okay, so what happens? The particles of the solute, we know that it is made up of what? Solute and what? Solvent, and that's how it is going to give you what? A true solution, correct? So, the particles of the solute in solution, this solution has some particles, we are specifically talking about solute particles, okay, pass through the filter paper. So, this is the filter paper which we have taken, it is a filter paper, students, okay, and we are trying to do the filtration. Now, tell me, what do you mean by filtration? What happens in the filtration? So, filtration, suppose this is a filter paper, there are different types of filter papers based on their porosity or size of their pores. Pores as in what? Holes which are present on the filter paper. Okay. So, definitely there will be some pores, there will be some holes, right? Now, whatever you are adding on the filter paper, if that substance or any components of that solution has the particle size is bigger than the pores which are there on the filters, okay, definitely they cannot get passed through these pores because the size of those components is larger. They are going to get collect here, and suppose here is the beaker and the other component which is very smaller, or the size of those particles is very small than the pores which are available or which are there on the filter paper, definitely they can pass through these holes, and that's how we can collect them. Okay. So, this is how filtration like separates the components of a mixture. But here when we talk about true solution, students, solute particles are very small, okay. They can easily pass through the pores which are present on the filter paper. They are very small, or they are such a small that when we pour the solution, true solution on filter paper, the solute particles pass through the filter paper. Okay. So, that's what we have mentioned it here. The particles of the solute in a solution pass through, they are going to pass through the filter paper, therefore, that the solute particles are smaller than the pores of the filtered paper. Okay, it is very simple. If the pore size is the pores which are there on the filter paper, if they are bigger than the components which we are adding, than the components such as what? Solute. Let us be specific, I am talking about solute into true solution. So, they are very small than the pore size, definitely they can pass through and we can collect them down. Alright. So, this is what is happening in the true solution. So, in a conclusion, I can say solute cannot be separated by filtration. If I want to separate, if I want to get those solute particles, I cannot do it by filtration because they are easily going to pass through the filter paper, and I won't be able to get the separation of the solute from the solution. I hope you all are able to follow till here. Okay, if I want to separate the solute from the true solution and I am using the technique called as filtration, it won't help, because solute particles are going along with the filter papers, and that is how whatever you are adding from the upside, it is getting collected in the beaker down. So, what you have done? No separation has done with the help of filtration. That is why we can say solute cannot be separated by filtration. Alright, quickly students, make a note of these 3 important points. If you want to, you can draw the diagram also, a rough diagram, so that whenever you are going through the notes, it will help you to understand it better. Alright. Yeah. So, when solution is allowed to stand undisturbed, the particles of the solution settle. This is known as solution is stable. Okay, so what is happening here in case of true solution? If you are going to allow it to, you are not going to disturb the solution, what happens after some time, the particles of the solution is, they are going to settle. Okay, then we can see, okay, some particles are getting settled down at the bottom of the container. That kind of situation is called as what? The solution is what? Stable. Alright. A solution is always transparent in nature, it may be colorless. Imagine sugar solution, imagine salt solution, do they have any color? No, they are what? They are always color, like most of the time they are colorless, or if they are having any color, but focus here, they are what? Transparent. Okay, we can see through the solution. Okay, so here is the example students, we have taken copper sulfate, okay, which like these are the crystals which are blue in color. Okay, here is the copper sulfate. Copper sulfate is a type of a salt which is blue in color, and that is your solute. Water is solvent. Okay, so here we have taken water as a solvent and we are making copper sulfate solution. So, what is the result? Okay, this is the formation of the solution, copper sulfate solution. So, students, it is a true solution because it is transparent type of solution. Okay, so make a note of this point also quickly. They are transparent, most of the time they are colorless, and like the particles can get settled. Okay. Is that done, students? Now, let us move ahead. We are having the next term called as concentration of solution. So, what do you mean by concentration? I am sure you must have heard this word concentration. Like, what does it exactly mean? Students, the amount of solute in a given solution is called the concentration of solution. We are going to measure the total amount of the solute which we have taken in the solution. That exact amount is going to give you the term called as what? Concentration of the solution. So, as proportion of solute and solvent is not even in a solution, therefore, depending upon the proportion of solute as a solution can be, like we can have the further classification as dilute solution and concentrated solution. So, students, try to understand concentration is nothing but the exactly solute amount of the solute which we have added in this solution. Okay. So, like the proportion of solute and solvent is not well fixed. So, here we are focusing on the amount of the solute which we have added in a solvent. Suppose if we are adding I am just going to give the example of what dilute solution. Okay. So, here I have taken salt and water. What I have taken? Salt and water. Suppose water is like 500 gram or 500 ml. Okay. And you have taken 5 gram of salt. Okay. So, here water is a solvent which is like large in quantity and your solute is lesser in quantity. That means I can say it is a dilute kind of solution when I have to compare it with concentrated solution. If I am going to add more salt and less solvent, okay, so the amount of the solute is getting added more than the solvent, that time I can say this is nothing but a concentrated solution. This is nothing but a concentrated solution. Okay. So, let's revise it like dilute solution, a solution with less solute concentration. Okay. So, this is a type of a solution where we have less solute, like concentration of solute is quite less, and on increasing the amount of water, solution can be further diluted. Here I have just taken example like 5 gram of solute is there and it is getting dissolved in 500 ml of water. Okay. And if you are going to add the amount of water, it is going to get what? Diluted. Correct. Concentrated solution. Now the next term which we have, the concentrated solution, solution with high solute concentration. Now here we are going to do the process in reverse. We are going to like increase the amount of solute and it can like further get concentrated. The concentration or the amount of solute is going to get increased, and that's how we are we can say like we have concentrated solution. It's not diluted by addition of solvent. Alright, so here is the picture of it. This is the solute, okay. This is a solvent which we have taken. It's a little bit of salt, like a solute is the salt here, and little bit of salt, more of solvent. It is going to give you dilute kind of solution. But here we have taken too much of salt, okay. We have like increased the concentration of the solute. That's how we can say it's a concentrated type of solution, okay. Quickly make a note of this, students. Is there any doubt, students? So here we have added less amount, or the concentration of solute is very less. Okay, here concentration of solute is very high. That's why this is concentrated, this is diluted. Okay, these are the terms, okay, which we are using. Just a minute. Yeah. So, let us move ahead and try to understand if we are having combination like this, solid and liquid solutions. Okay. So, here students, if a solution is prepared by dissolving a solid solute in a liquid solvent, the concentration of the solution may be expressed either in mass percentage or mass by volume percentage. Now, what is this? First of all, we have taken the combination such as what? Solid and liquid. We have prepared a solution in which we have taken solid and it is getting dissolved in liquid. So, solid becomes your solute, liquid becomes your solvent, correct. So, that type of solution which we have. Here the concentration of the solute which we have added in the liquid or in the solvent can get measured with the help of two terms or with the help of two concepts, such as either we can measure in with the help of mass percentage or mass by volume percentage. Okay, mass percentage or volume or mass by volume percentage. Now we are going to understand these terms. Here we are moving towards the mathematical part of the chemistry, students. If I want to measure how many solute, like what is the quantity of that solute which I have dissolved in the certain amount of solvent, I have two ways to calculate it. Okay, so first is mass percentage and the second one is mass by volume. Okay, so here is the mass by mass percentage. Okay, this is the method 1 or term 1 to calculate to measure the concentration of the solute. The mass of the solute in grams dissolve in 100 gram of solution. Okay, how, like what is this, what are we doing by this? Actually we are going to calculate the mass of the solute. Okay, focus on the word mass of the solute or concentration of the solute, which is it is getting measured in grams, mass of the solute in grams, which is dissolved in 100 gram of solution. Okay, it is dissolved in 100 gram of solution. This is what is the equation for this or formula to calculate the mass of the solute. Okay, in like mass by mass percentage. Students, this is how we represent it: small w, then capital W, and this is the sign of percentage. It shows mass by mass percentage, mass by mass percentage. Okay, so what we are doing here, we are going to take the mass of the solute, okay, and we are going to divide it with mass of the solution, and it's a percentage, definitely we are going to multiply it with what? 100. Mass of solute divided by mass of solution into 100. It is going to give you the concentration of the solute, but how? By mass. Alright, I repeat, the mass of solute in grams dissolve in 100 gram of solution. Okay, that is what the mass by mass percentage of solute. How do we calculate this? We are going to take mass of the solute and it is being divided by mass of the solution, and we are calculating percentage for this. So, into 100. Is it clear? Students, just quickly make a note of this. It's very important. There are some numericals which are based on this topic. So, if I want to measure, if I want to calculate the concentration or mass of solute which is present in the solution by mass percentage. Okay, so read carefully the term. It's mass by mass. Mass of solute divided by mass of solution, and it's we are calculating this in percentage, that's why into 100. Okay, soon we are going to see one example so that you will get a clarity on this. Is it clear? Have you all taken it down? Yeah. So, we are having one example here. For example, a 10% of solution, okay, 10% of solution of common salt means what? Means that 10 grams of common salt are present in 100 grams of solution. Okay, so what is this? If I want to prepare 10% of solution, okay, or salt solution, I am writing here as a sodium chloride. Okay, so if I am asking you, students, prepare 10% of salt solution. So what you are going to do? What you are going to do? Students, try to understand. You are going to prepare this by adding 10 gram of salt in 90 gram of water. Okay, 10 gram of what? You are going to take 10 gram of salt and you are going to dissolve it in 90 gram of water. Okay, this is going to give you 10% of salt solution, NaCl solution. I am just writing it here. So, how are we going to prepare it? 10 gram of salt is getting dissolved in 90 gram of water. Okay, it is going to give you 10% of sodium chloride. Got it? Yes or no? Suppose if I want to prepare 20% of sodium chloride solution. So, what you are going to do? You are going to take 20 gram of salt, but in 80 gram of water. Okay? Is that clear? Okay, so quickly make a note of this too. Let's move ahead. Students, now the next concentration term is what? Mass by volume percentage. Mass by volume. Mass, that means W we can show, by volume percentage. Okay. So, here is the next term which we are going to discuss here. The mass of the solute in grams dissolved in 100 ml of solution. So, it's mass by volume. Volume we measure it in 100 ml. So, here the solute, of course, we are going to take it in grams. Okay. So, mass of that solute in gram, and like which is getting dissolved in 100 ml of what? The solution which we have taken. So, it's by mass. Okay. So, we are measuring it in mass, and this is we are measuring this in volume, and solute is like we are measuring it in mass. Okay, that's how I can say it's mass by volume ratio. Okay, we are going to take some solute and we are making it dissolve in what? Liquid, or we are going to measure that solution in terms of volume. That's why it is 100 ml of 100 ml of solution. So, how many gram of solute you have dissolved? That is what we are going to find out by solving some numericals. But firstly, try to get the definition or the term very clearly. So here is the formula, students, quickly make a note of this. It is very simple. It's like mass by volume percentage. Okay, so mass of the solute, of course it's in gram, volume of solution it's in ml into 100. Okay. So next example is that if I want to prepare 10% by volume solution of common salt. Here we are focusing on the word by volume solution. Students, by volume, that means like the water which we are taking, that has to be in ml, not in gram. Okay, it's not mass by mass, it's mass by volume percentage. So that means 10 grams of solid salt, which is solid, and the unit is what, gram, is present in what, 100 ml of solution. And how are we going to prepare that? Suppose I am going to take 10 gram of salt and I am going to dissolve it in what, 90 ml of what, water. Focus on the units ml, it's liquid, we are going to measure it in volume, so that means the unit has to be milliliters, and 10 gram of solid, which is like salt, right? And that's how it is going to give you 10% of volume solution of salt. Correct? Is it clear, students? Yes or no? Quickly you can make a note of this formula and this example too. So here students, we are learning concentration. Okay, concentration is nothing but the amount of the solute which we have added in the solvent. Solvent can be a solid, solvent can be liquid. Okay, so if we are having mass by mass percentage, students, here we are going to take mass of solute divided by mass of the solution into 100, and we have the next term, that is what, mass by volume. Here solute is again in solid state and our solution is what, in liquid state. Here we are measuring its volume in ml, correct, into 100. Alright. So students, that was all for today. We are going to continue with the session like next time. Till then, if you are having any doubt, whatever we have learned today, like with this, if you are having any doubt, you can ask. Okay. Students, we are meeting in the next session. Okay, we are going to continue with these terms, concentration terms, and we are going to solve some numericals based on the same. All right. Okay, so till then, bye bye, take care, keep studying.